All right, so I thought I would just take a second to explain this question from our in-class assignment, lesson 7.2 and 7.3. The reason is because I think there was a little bit of confusion around the inequality and how this was distributed and how you need to think about these things. Because in class, I always explained it in a very particular manner, and there was a reason why. And maybe I didn't tackle that in class as best as I could. Here's where I'm going to clearly explain why we have to have it in our piecewise function in a very specific way. Now, when I map this out, here's what the following happens. So we take an absolute function of this in question number 4 of g of x equals the absolute of 5 minus x, and it can be written as some sort of piecewise as such. Now, the piecewise that represents this is the following. Now, if I took that function of 5 minus x and I rewrote it, I could obviously rewrite it in the following manner. I could rewrite this as g of x is equal to the absolute of negative x plus 5. And we would read this line as it's the negative slope of 1 over 1 that passes through 5, aka that first piece would be this line here. So we'd have a line that if we were to extend it, obviously, and make it not absolute, it would look like something like this if we took that original 5 minus x or negative x plus 5, if we wanted to write it that way. Now, we're thinking, okay, well, when does this occur? This part of the graph occurs, or this left-hand side of the graph occurs, when we have that first part here, that first piece or that original piece. If we ignored those absolute value bars for a second and we just wrote, oh, 5 minus x, it would give us this line here. And so we're on the left, and that occurs when it's less than the 5. Now, in more particular, if it's the original graph, or if this represents that original piece of the absolute that they gave us, then what we need to do is always attach the equals to it. Now, why do we always attach the equals to it? Here's why. If we then take the absolute and we go over to the other side and we consider where this is the negative variant, or it's g of x is equal to the negative 5 minus x, this would reverse both of the signs to make it x minus 5 instead. X minus 5 is where we have the positive slope, and if this is the positive slope and it also crosses through that exact same point, here's the issue. If I have a line that crosses this way and it goes through that point of 5 as an x-intercept, and I have this negative slope that crosses through, we then have two different functions, one negative, one positive, that cross through the same point. And as we know from Math 10C, that doesn't pass the vertical line test, because the vertical line test would cross through this x-intercept of 5 at both locations. And so if it crosses through that 5 at both locations, where we have the negative slope and the positive slope both crossing through that same point, we only can have one of them equal to the 5, because if they both equaled 5, then it wouldn't pass the vertical line test. So you want to almost think about it as this one, which is the original, is going to pass through that point. And then this line is going to go and approach that point, but have a hole at that graph, because if the positive slope has the hole and the negative slope or the original actually has the point, then when we sandwich them together, this one includes the point, this one has the hole at that point, therefore it's only accounted for one time. And if I drew the vertical line test of this graph, it would pass the vertical line test because it only crosses through that x-intercept one time, because this was equal to 5 only at the one function. And so if we were to adapt our solution here and we look at the appropriate solution, here's what we need to look for. And here's why I exempted it on this question, because when I scan these, first and foremost, I want to have it so that the functions are right in the first place. So I scan down the list of functions and I'm like, okay, 5 minus x is definitely the original, but x plus 5 is the same function. It can't be this one, because these two are actually the same thing, just written in a slightly different order. Then I go down to something like this one. We have 5 minus x and then they're both positive. Well, if one's negative and then they're both positive, that doesn't make sense. That's not what absolutes do. They don't just make both values positive, they flip the values. So that one doesn't work. So A and B are both off the table, leaving us with these last ones, x minus 5 and then negative x plus 5. That could be a valid solution. And we have x minus 5 and 5 minus x. So these are both valid in terms of the functions they gave us, but now we need to see if the inequalities make sense. Is it true that the x minus 5, or that the positive slope, is occurring when it is less than 5? No, because it's all of the values that are this way. This is where the positive slope is. So when they say it's less than 5, this one rules it out right away. So we would look at this and be like, it can't be A, it can't be B, because those write out the wrong functions. C has the wrong domain for each of the sections, so it must be this bottom one. Now, in the case of the solution here, I'm just going to erase that for a second because I made a correction when I was doing my solutions, hence why it's exempt, is the following. Where the positive slope is greater than or equal to 5, we just said that that's not going to be true because it must be that the original, aka 5 minus x, is the part that's less than or equal to 5, and that the other piece, or our negative slope, must be, or sorry, our positive slope must be the part that's strictly greater than. So in this situation, they have the original that's less than and purely less than. It must have an equals on that because it's the original. And then our other one where we see, hey, x minus 5, which is the positive slope. Remember, when we draw this new graph, we want to have a hole at the x-intercept such that we're not double counting the value, and therefore this is just a strict greater than. We don't want to have the equals in there, so I'm going to write right over top of it that it is greater than. And I want to make this as neat as possible when we do this. Perfect. So no equals. It only happens when the positive slope is strictly greater than the 5x-intercept. And so if I was to formalize the solution, here's what I would do. I would always want to start with the original at the top of the piecewise function, and then I would want to end with the negative variant or the flip variant of it. And essentially, if I was to write this out, like I could take this one step further and be like, to make this look like something we would have done in class, I'll write it in red. I would take the negative of 5 minus x, and then this would be where it's greater than 5, which is the same thing. It's literally the same thing, no difference. The only thing we did was just distribute the negative in order to put it in this black version here, or to match our solutions here. So be very careful with this. We want to pass the vertical line test. If we're going to pass the vertical line test, we must have it such that the function, or the original function, includes the x-intercept and the new one doesn't. You could make an argument that it's transitive, that realistically the equals could be on either one, but only on one of them, of course, but it could be on either one. But for the most part, we always want to say it's attached to the original because the original is going to have always that included value.